Hi, and welcome to this demo of my game for Ubisoft Next. So, I built a complete, feature-rich, feature-complete 3D engine and physics engine from scratch. Now, you might be asking, how are these polygons filled? Are you using OpenGL code? Well, no, I'm actually not. The way I fill in these polygons after I've done the necessary 3D projection and things that come with building a 3D renderer, which of course I did from scratch, is I use a scanline rendering technique that I developed from scratch myself. So let's say we have a triangle that's projected onto the screen after the object has gone through object coordinates to world coordinates to projection space to screen space. It'll sort the vertices of the object, and we can see that sorting happening right here. It uses Painter's algorithm, so this is just rendering back to front using Painter's algorithm, which results in some issues that we will see later. So it draws a line across from B, and it labels this D, labels this C, finds the slope of this line, the slope of this line of the triangle, and it says for every 1 pixel move down in Y, what is the change in X, and it draws a line that big for that triangle, and then just does the same for the bottom half of the triangle. And that way we actually get a surprisingly good implementation of polygon rendering. Of course, these artifacts are due to the fact that I don't have access to a depth buffer because I can't set the depth per pixel because drawline is the only method available, but we have to make do with what we have. So we can see over here that we have a ball. It says player 1 turn to move. This physics engine is using Verlet integration and Euler integration. Verlet integration for resolving collisions and Euler integration for handling the gravity stuff. All of that is handled inside this physics system.cpp file over here. And actually, this entire engine is using what's known as an ECS, which is an entity component system designed from scratch by me. So we can see within components.h, each component is defined, and then I can use it in a very similar way to the way that Unity works, which is the engine that I'm actually comfortable with outside of doing low-level graphics programming. So I can use Shift with the WASD keys to kind of look around the scene. And I can use the left and right arrow keys to rotate this aim pointer. Then I can hold down space and actually get the ball to roll this way, as you can see. So we can see that now it has switched to the player 1 turn to move, and both players have 1 stroke left, they have done 1 stroke. And when the ball actually goes inside of the hole, it is going to show that the strokes have been subtracted by 2, as you will see in a second. So now we're back to player 1 turn to move, and I don't have any other scenes set up. So I actually have a scene manager that I developed from scratch for this, but I don't have any more scenes that are coded within this. The scenes are also defined very, very nicely and modularly. As you can see over here, I have a nice little helper function for loading the scene, and then I actually have these functions that create the scene itself. So we can create the physics object, and the implementation of this is just it's adding the necessary components. Every single entity at the end of the day is actually nothing. It's just an empty object with a bunch of components that are attached to it, and the components are what give it value, as is with any good entity system. I can also go through a little bit of the physics code. As we can see in the update function of this game test file over here, I call this physics system.update every frame, and the physics system.update is what handles actually calculating the Euler integration and then finding whether the collisions are happening, and then it resolves the collisions using this function, unless it's a trigger, which is a different type of rigid body that I have. And this physics engine is extremely feature complete. I mean, it doesn't seem like it here, but I've tested it with ramps and jumps and all sorts of other things, and it works beautifully. I just did not have time to actually build a level that utilizes all of this. But as you can see when you will play the game, it's a little bit difficult for me to get it into the hole. But as you can see when you actually play the game, when the ball goes into the hole, it responds dynamically with it. Oh, okay. And the ball's about to fall off, and we can see that when the ball falls off, simply falls back, and the stroke is moved to the other player. Everything is very bug-free and nicely implemented, and the performance of this engine is also quite nice, I would say. And so now it's player two's turn, who's of course back here because they fell off the thing, and yeah, that's it. Thank you.